And I'm from the EOSC Secretariat project, and I will lead you through this online event. Should you have any questions, you can ask them in the Q&A chat below, or make sure that you don't use the normal chat because we might lose this question in the mess of questions asked. We have been in this pandemic for more than a year now. Who would have thought that a tiny little virus would be spreading that quickly around the globe, causing fear and horror to so many people? Who would have thought that the scientific response to that little virus would be even more astonishing? I often catch myself, also with some friends of mine, worrying about the future. What are the current numbers? What are the actual regulations? How will the situation develop? For how long do we have to remain in these more or less annoying lockdowns? But I think we could more often, and we will do that in a couple of minutes, also look into the past and be proud what science has accomplished. It is really impressive what open science made possible in that very little time. One great example is the development of the European COVID-19 data portal in order to accelerate coronavirus research. It enables the rapid collection of research data as well as comprehensive data sharing from different sources for the European and global research communities. This joint effort is a priority pilot to realize the objectives of the European Open Science Cloud. Looking back at the beginning of the pandemic, we as EOSC Secretariat were adopting a co-creation approach by providing budget for all upcoming foreseen and unforeseen activities related to the work and strategic objectives of the EOSC's implementation. This included deploying open science infrastructures, services, practices, data, and networks for addressing unforeseen activities of the public and humanitarian interest, such as the COVID-19 pandemic. So we responded, and by introducing fast-track funding opportunities for activities and actions that deploy open science methods and resources there. We wanted to make use of the EOSC communities in order to address any kind of COVID-19 related issue. This could have been any activity that is shown on this slide. In order to evaluate the proposals, we gathered an expert team consisting of 6 people to evaluate the incoming applications based on their credibility, originality, duration of the project, and power of reuse. On a weekly basis, we were fighting through 311 applications in total, and we're very proud of the great variety of interesting activities we have received. In the end, we spent more than 2 million euros on 57 projects based in 21 different countries. A full list of the funded projects is available in the co-creation section on our website. Some of you may remember, and I remember some of you being there, that we made a rather small but quite long online event in early September last year. There, we discussed and sort of kickstarted many activities which were brought up. We were asking interesting questions about the different actions and identified common interests. It was a pity that this event, just like this webinar now, needed to be online due to travel restrictions. However, it was very successful and the participants were very interested in the results of the presented activities. So I'm glad to see that this webinar is that well attended, and I'm looking forward to the next 1.5 hours. As mentioned, we faced and funded a huge variety of different projects and are very pleased that we can now read about the results of all these activities carried out. Out of them, 4 exemplary stories will be presented to you now. If you're interested in more, you can also check them out in the EOSC Stories section on our website. For now, I will leave the floor to Jamal Jokar Arsanjani, who will talk about his project, Artificial Intelligence and Geographical Information for monitoring and prediction of the COVID-19 outbreak.
Thank you very much, Bernd, for the introduction. My name is Jamal Jokar Arsanjani, and I'm from Aalborg University, Copenhagen. I'm here. I'm delighted to present my study, the study that we conducted within this funding scheme, which was titled AI for COVID, and the full title is Artificial Intelligence and Geographical Information for Monitoring and Prediction of COVID-19 Outbreak. So this study was done together with a colleague of mine, Frederick, at Aalborg University. So we are happy to present the findings of our study within this short period of time. So I'll be happy to take your questions afterwards, and also if there are follow-up questions, please feel free to get in touch with me afterwards. So as per the objectives of the study, we basically aimed at two main objectives. The first one being presenting a data-driven approach for exploring the spatial temporal patterns of the pandemic over two different scales: a regional scale, which is Europe, and also a country scale, which is Denmark, as we are basically based in Denmark, and we have been observing the fight against COVID-19 across the country, and we could have a good benchmark of what we did and also what our models told us. And the second objective was to explore what geographical variables potentially contribute to expediting the spread of the pandemic, so that we basically could use those variables in order to do a better planning in terms of lockdowns, reopenings, and society management. Our approach and our study was quite data-driven. So we basically looked into a wide range of data sets, and I'm talking about geographical data sets. So the main data set that we used as per looking into the number of COVID infections and infection rates across Europe was the data set which is provided by the European Center for Disease Prevention and Control, as you can see the link to it in the slides, and also a set of other geographical data sets such as population density, public places per capita such as restaurants, cafes, fast food places, pubs, bars, gas stations, schools, medical offices, and kindergartens. And those locations are basically places that people gather, and that could be a source of increasing the number of infections. And also we extracted some of the other variables from Copernicus program, from the Sentinel satellites, and those are annual mean temperature, nitrogen dioxide, and PM2.5, non-methane VOC levels, and also PM10. As you can see also on the right-hand side, the visualization of those factors. As per methods, we basically went through a set of methods. The very basic one, the very first one was basically looking at the historical development of the pandemic across the planet, Europe, and also Denmark, where we basically looked at the number of cases per 100,000 inhabitants over a 2-week period, so that we could see how the pandemic and the infection rates started to emerge and evolve across the space. So that's basically the kind of animation that we have been seeing all over the place. But what we tried to do was to basically look at the problem from a geospatial perspective, from a geospatial, let's say, view angle. And that led us to go into the second method, which we basically use a spatial autocorrelation in order to extract more relevant indicators and more meaningful indicators out of this whole mass of geospatial data. And basically this spatial autocorrelation is a very core concept in geographical information science, where basically you're given the opportunity to identify where clusters are appearing. And by clusters, I mean clusters of hot values, let's say high values, which we call them as hotspots, cluster of low values as cold spots, and also some intermediate patterns such as diamonds and donuts that basically they represent where there is a hot spot or a cold spot being surrounded by, for example, cold spots and hot spots. And that allows us to basically have a better control over our lockdown planning, so that we don't have to necessarily lock down the entire country on or the entire planet, the entire continent. So we basically could differentiate between different geographical regions so that we have a better control over not necessarily closing down the entire country and giving our people a slightly better freedom of movement. As you can see here, they are represented in different colors, and you can see how this pattern looks like across Europe, where if you also compare that to the numbers that you receive in your own country, you can see that is reflecting to a good degree what was happening in your country. Especially in Denmark, that was the case, that the capital area was quite highly impacted. And every now and then a small city in the country got a lot of infections, so that those small municipalities and small cities had to be completely locked down. And that also led us having a spatiotemporal data set of COVID-19 cases, allowed us to basically take it to the next step by injecting a temporal component to our data set. And that allowed us to do a space-time autocorrelation, which basically gives us an indication of how, or let's say, to end up with a wide diversity of different space-time patterns. Those hotspots and cold spots could be more explained with like more diversity of subcategories, so that we could see which of these hotspots and cold spots were quite persistent, and some of them were quite newly appearing. So that allows the decision makers and health authorities to basically have a different treatment or a different behavior towards those kind of small patterns. And the last kind of set of tools that we applied to our data set was basically try to, and that was the main objective of the study, and that was to basically explore which kind of variables and which kind of factors are quite impactful, and they contribute to the expansion of the pandemic. And to do so, we basically went through two families of methods, one being statistical methods and the other one being machine learning methods. And as per statistical methods, we basically went through linear least squares and GWR, geographically weighted regressions, which are basically two different versions of regression models that one is being quite geographical, meaning that it respects coordinates and location of features. And our results indicated that the achieved correlation, R square, is a lot higher, is substantially higher compared to a non-spatial model. So that proved that this whole COVID-19 expansion across the space is a very geographical phenomenon, which needs to input a lot of geographical concepts into a better understanding of it. And as per the machine learning methods, we basically looked at a set of machine learning methods where we looked at a European, let's say, coverage, and also a country level coverage, where we basically ended up to accuracies around 76%. Looking at the accuracy numbers, I must say that accuracy numbers are quite varying from very low accuracy levels up to quite probably saying acceptable accuracy numbers. And that is basically, just to be completely honest, is that this problem is a lot more complex and a lot more complicated than being easily modelable. And that brought us to some maybe course findings, I would say. At least our study indicated that there are among these 10 or 11 indicators that we put into our models, 5 of them were quite deterministic. 5 of them were quite influential, and those were population density, location of public places such as cafes and bars, and 2 measures of pollution levels, one being non-metan VOC levels and the other one being PM10 levels. So our variable importance also indicated that those are a lot more important compared to the rest of variables. So some maybe generically speaking lessons learned here, not to focus on the implication of the methods from a geographical perspective, but just generally talking about the lessons that we learned from this study, was that pollution levels can be explicitly used to monitor lockdown measures and infection rates. So especially since COVID-19 is a kind of disease that has a lot to do or has a lot of interaction with our respiratory system, basically pollutions and pollution levels can be quite helpful in order to basically predict and track what to expect. And from identifying the hottest spots and coldest spots of infections, basically we could use that part of the study in order to apply varying lockdown measures, not necessarily closing down an entire region or a country, so that basically instead we could just have regional lockdown measures, or let's say local lockdown measures. And those influential deriving forces that I explained in the slide before, basically they could be used for prediction of the upcoming events and infections. Our study did not basically have the time to look into that direction and that dimension, but basically we could use the models that we have tuned in order just to look into one time step into the future and see what could be the future, the tomorrows of infections, so that every health authority could basically predict what to expect next week to a good degree, to an acceptable degree. And our the other lesson that we have learned was that there are some factors that I would call them soft factors, that they are not accessible, or we could not basically incorporate them into our models because they are not measurable. And those could be an example of those could be, for example, since we have been just applying different lockdown measures across our countries or entire Europe, that kind of action could not be, or there is no basically variable in order, a kind of quantifiable variable in order to use that into our models, because there was a lot different if a country was quite strict in terms of closing down their facilities and their societies, while some of the countries have been quite the opposite. I'm talking specifically about Denmark, where there were a lot of strict measures not to let a lot of businesses and a lot of society, a large part of the society to be open, while for example, in Sweden or other countries, there was not that much strict measures in order to keep our society, say, super close or super open. And speaking of data, which is always a limitation when it comes to data-driven studies, is that the scale of data that we used was maybe rather okay, but if we want to achieve better accuracies, we need fine scale data. And for that purpose, we need to have the infection and COVID-19 related data at a much better scale, something like neighborhood level or building block level, or something much finer than provincial or municipality level. And some general conclusions out of this study that I could briefly talk of would be: geographical data and tools and methods can provide unique insights to the understanding of the pandemic or emergencies such as pandemic. It's just because we have seen geography or COVID-19 or the pandemic has had a geography, and that demands a better contribution from geographical information science into looking to the problem, so that we could have a better understanding of that. It's not always just a lot of pressure on the medical understanding. There are different dimensions related to emergencies such as pandemic that we need to basically have those also into our studies and our decision making. Our choice of data, specifically in the study that I mentioned, our choice of data and methods along with the presented results could empower health authorities and decision makers, governors, with an interactive decision support tool, which can be useful for imposing geographically varying lockdowns and reopenings. So what we have done has been done in an open science setting, so that the entire data sets are accessible for everyone, and also the scripts and the codes that we developed within this study are also accessible, so that basically you can reproduce the study and also expand our study using a different data set that you would like to incorporate into the model. As per future work, we would like to suggest including further variables that reflect the lockdown levels into local regions. It's just I think that's a general understanding that such a pandemic is a lot more complex than any other dynamic phenomena that we have been dealing with. So there are still a lot of untold stories about it that maybe time will tell, or later in the future, we will see what aspects of this pandemic we basically forgot to look into. So I hope I paved the path for future studies. Thank you very much for your attention. I would like to encourage you just to go through this paper, this journal article that we have published out of this study, which has been published into the International Journal of Environmental Research and Public Health. And also you may access our data and approach in this GitHub repository. So I believe the slides will be available on the website of EOSC. So please feel free to just click on the links in the slides that whenever you need more information about the details of the study. Questions and comments and inquiries, please feel free to get in touch with me. And of course, that includes also now in the QA session. If you have any questions, please feel free to pose them. Yeah, thank you very much.
Thank you very much for your nice and detailed presentation. We received 3 questions, but maybe since we're running a bit out of time, we just ask 1 question and leave the other questions for the Q&A session afterwards. Would the model also be applicable for other infection diseases?
The short answer is yes. But that requires us to have a general understanding of the other disease that we are talking about. So the nature of COVID-19 has been quite different, especially like personal contacts and closure has been the main driver of the pandemic. But if we are talking about a similar case, that's definitely doable. But even though the other disease that we are talking about, that this question is meant to address, basically a slight tuning, a slight modification of the model can basically address that. The main, I would say the main contribution here is that the platform and the setting is already made so that this could be used as a base camp for extending such studies and such models.
Thank you very much. Then now we will leave the floor for Andrzej Jarynowski with his project, a dataset of media releases from Poland related to COVID-19 for open research.
Hello. So I would like to tell you something about media research in the context of pandemic. I'm epidemiologist, and I usually work for sanitary inspection and clinical trials. But here, this is a project of mine with an NGO, which is not my normal place of work. And I will concentrate a few examples how to use media monitoring for polarization processes, for protest analysis, and what is the perception of vaccination. And we use different data sources: Twitter, Facebook, news, YouTube, methods, topic modeling, sentiment analysis, and dimension in epidemiology and social dynamics. What is something new, because most of the tracks we followed is standard in infodemic studies, but what is new is participatory epidemiology, which is quite new phenomena which appear in pandemic time, especially in East Europe. We deposit, of course, our collected data set. I think what is important for future researchers is that we manually labeled quite intensively with 45 variables each text for future machine learning purposes, for fake detection. And I think this is already happening, especially in a non-English speaking environment, because when we deposited our data set in summer, they were only English or Arabic really available for machine learning and artificial intelligence labeled texts from pandemic. So now this is a very extending field of research. And what is quite important that our delivery lists were focused on Polish society, especially Lower Silesia. That was our goal to share our not only data but also the results of our analysis. Everything is linguistic context. There were some phases we were able to detect with our methodology according to intensivity of information propagation, emotions, topics, dominating topic in each phase. What is most important for you to take home is that the social context of pandemic was the most important and the most frequent use in the media. So not medical, not the governmental outbreaks description. No, the social context was what the people were talking about and what they want to listen. And I will not bore you with our deliveries for our policymakers in Lower Silesia, but we were able to identify who were the most influential actor in the media and what was the timelines in our region. Why it's future? Because my city, my region was experience with pandemic before, and it will be experienced with pandemic in next year. So after doing a short time analysis, we were able to reuse the same data sets we already collected to make some scientific questions for future. So one of the issue is deterioration theory. So every society during a crisis have different phases, and the phase of mobilization, phase of deterioration, and coming back to the normal system. And we were trying to look at that from polarization perspective. And Poland, as every country is in Europe, in the world, is quite polarized due to politics. We were able to map it before the pandemic and look how it changed during pandemic. And we found some kind of depolarization periods, and we need to investigate it further, because this is quite important. But because people think that social media is wrong or something usually bad, but we can also look at the processes which are positive in the social media. Yeah, we could monitor the protest movement and check how the health communicates, propagating in this protest movement. The vaccine context is very important because we can profile potential targets geographically and according to their social status. We were able to make a regional diversification of potential action we can do for proper health information, and the media could be used for surveillance of adverse effects of vaccine. Of course, this is another thing we are doing. We are monitoring how people are describing the adverse effects from vaccines in the media. And to make you some home message, this is the pandemic in media is definitely a social issue, not medical. So for example, if medical doctors and the colleagues we used to work, they believe in the positivistic philosophy that it is enough to inform people and then they will follow the guidelines. But this is not like that. The social system is much more complicated, and you need to understand how exposure to information could be translated into the action, and this is not simple. We found that the regional media are much more reliable for in comparison to national. This is quite important for you working in your local environment. That probably sometimes it could be better to get in contact with your journalists from local newspapers, local social media influencers than from national. Campaigns must be, of course, targeted. And the data should be open. So there are some public health, public relation agencies or media monitoring agencies which do monitoring, and they sell reports, but they don't show the data they are using. And our philosophy is totally opposite. So okay, we do the same analysis, but we also give the data for replicational purposes. And remember that social media can be also good, and if you use it properly. Okay, thank you for your attention.
Thank you very much for your nice presentation. And since there are no questions from the audience, we will leave the floor directly to Ernesto Pedrosa with his project Automaise EOSC COVID-19 Digital Assistant.
Hello, good morning. Thank you, Bernd. Just sharing my screen. Just give me a second. Get things ready. Okay, so yeah, I'll present you the part we built in co-creation with EOSC, and where we created this assistant to tackle on some issues that we we figured out sometime last year. So, but before jumping on the product, I'd like to kind of give you a brief presentation about Automaise. So Automaise is per se a low-code AI automation platform that enables rapidly building AI-powered solutions. And we combine different AI techniques in a single platform to deliver what is so-called hyper-automation. And that's exactly the platform we use to address this problem that I'll describe in a second. So, but why Automaise, a private startup, joined this project, this fight, is because we felt it was our social responsibility to also help tackling COVID. So, and therefore we kind of put our best, let's say, knowledge also to help fighting COVID. So back in March 2020, when let's say the first wave hit Portugal and a bit across Europe, we clearly see some issues that were kind of arising. The fact there was not enough available tests for testing the COVID, so people was kind of lost where they feel sick, but they were not able to test. There's also lots of poor and misinformation circulating around in social media and other media types. And of course, there was a high pressure on the medical staff, especially on the health-related hotlines, where people was calling all the time to check whether they have COVID or not. So, and we clearly spot the need for an AI-powered assistant to help answering some of these questions. So we have created with an assistant that was able to answer, not only to do the screening process, but also answering some questions, doubts, and provide recommendations as well. So as I said, all this functionality is built on top of AI. We have deployed many AI models to support this solution. We have implemented a screening process, and this screening process was validated, designed and validated by the Health University of Minho and University of Porto. They were both involved in approving or designing and validating this process. We also set up a wide list of frequently asked questions, as well recommendations, and we provide this information in 5 languages as of today. So English, Portuguese, French, German, and yeah, that's it. And Spanish, sorry. And we also believe that a solution for like this needs to be managed by anyone out there. So no engineer required, no data science required. You just deliver a human-like self-service interface for everyone virtual out there, being in charge or being capable to help training the machine, for instance, or even configuring or adjusting the screening process. So this project was developed during a period of 3 to 4 months. Actually, the initial timeline was 3 months, but then we ended up taking almost 4 months to deliver the project. The team was composed by five people: 2 data scientists, 2 developers, and 1 delivery manager. And one of the main issues that we found during this process was the lack of training data to train the system to understand human language, right? So the COVID language, sorry. And for that, of course, we had to deploy some effort as well on generating data, and also labeling data so that we could train the AI so the AI gets knowledge about COVID and all the symptoms, the recommendations, all that stuff. Okay, now seeing a bit of the real thing. So are you seeing my screen, the video? Yeah, I think yes. So as I said before, it's all powered by natural language. Right now, someone is asking about the symptoms of COVID. We are now triggering a process to do the screening process, the screening to check whether this person has COVID or not. So for this process, as I said before, it's let's say the official flow or the official screening process that was put in place by the health institutions. Was also validated by the universities, and we are gathering all the symptoms, making all the questions, and at the end we'll come up with a prognosis for according to the symptoms that were provided. Now that this person is just indicating the symptoms. Okay, and this person got a red message, meaning that most likely this person has COVID, taking consideration all the symptoms that were provided, and this person should immediately contact the health authorities for next steps. So in terms of the interface where someone can supervise all this solution, it's visually. We have created this dashboard where you can see all the metrics from the operation of the digital assistant. We also have on the right top corner all the area where we can visually train the AI of the machine. So basically start introducing or delivering more knowledge for the machine so it gets smarter. And then all the AI are automatically trained on the back, and new models are available on the fly. We have metrics, and of course we have some configurations that can be done also visually, because we do believe that this solution needs to be maintained by anyone and not requiring developers or data scientists every time someone needs to change something. So the goals for the product, and the list we kind of put on the whiteboard, and where the goals for the product was, of course, reduce support pressure on these hotlines, mitigate lack of available COVID tests. That again, it was 1 year ago. Alleviate stress and anxiety on people, because people was kind of lost whether they feel sick, may I have COVID or not, or I have doubts about COVID. So that of course provide proper information from our own official source, because the idea for this assistant is to be the official EU assistant for COVID, so people will trust on this data source. And again, with this, stop misinformation and fake news, as this will be an official source with all the information being certified before being public. Reduce cost as well, because they were a high stressor on this hotline, so they were deploying agents. They are not available agents to reply to all the phone calls. So of course that was also let's say indirect result. And of course, all these models, AIs, trained data sets are now made available in Zenodo for anyone out there who wants to build on top of this. And we do believe that this kind of data needs to be shared, needs to be public, because the thing that we learned from COVID is that although there's a lot of data out there, it's not centralized, it's not accessible. We Automaise feel that in our skin when we try to train the assistant. We basically need to generate data ourselves, because we didn't manage to get access to other sorts of data. So data needs to be available. The models are also trained and out there for anyone who wants to use them. So for more information about this project, you can always check the drop we did on Zenodo. It's all there, the models, the trained data sets, even the source code. And as well, you can test the system by yourself. Go into EOSC COVID-19 Automaise.com. It's the English version. Feel free to use it. And yeah, and thank you very much. And if you have any questions, just feel free to ask.
Thank you very much for your nice presentation. We received a few questions. The first one is, are you using your own technology for chatbot implementation, or Reva or something else?
It's our own technology. It's built on this platform that I mentioned before, Automaise platform.
And the second question is, do you ask users if they are satisfied with the answers?
Yeah, we have this thumbs up, and thumbs down. Although it's kind of disabled for this link I've shared with you. We have this thumbs up, thumbs down, yes, for getting some feedback. Yeah.
Thank you very much. Since the next question is for all the presenters, we will leave that to the end.
Okay, thank you.
And now we got to our last presentation, Ivana Mišová, on her project, up-to-date mapping on COVID-19 treatment and vaccine development.
Okay, so thank you for the introduction. I would like to talk to you about our project, which is called Up-to-Date Mapping of COVID-19 Treatment and Vaccine Development. So first, let's look at what happened in research in 2020. So the pandemic of coronavirus has brought an unprecedented focus of the world's research on a single topic, with about 4% of the total research output was focused on coronavirus in 2020. By the end of last year, more than 200,000 articles were published on the coronavirus, and by now this number reaches about 400,000. So this is a staggering number of research articles, which is really challenging and difficult to use it and properly absorb this information. This information surplus is challenging for the research experts who absolutely need to stay on top of the data, but it is also confusing for the general population that often receives incomplete, biased information from various public figures of authority that are not experts in the field. Moreover, the articles on coronavirus focus on various aspects of the pandemic, such as the diagnostics, testing, modeling of the epidemic, mental health, or treatment options, which makes looking up the specific information you want even more laborious. So what the situation called for is an efficient way of processing all this data and making it available. So to this end, the goal of our project was to provide up-to-date research information on COVID-19 treatment options and to provide it for researchers as well as for the general public. First, it is important to identify the relevant sources of research data. So we focused on the renowned scientific databases, such as the lead COVID project based on the PubMed database, preprint servers such as bioRxiv, and data from the COVID-19 Open Research Dataset Challenge, which has data specifically ready for AI processing. So we not only accumulate these relevant research articles, but we also sort them by the effective substance. And by now we have more than 1,500 substances in our database, which is freely accessible on our site, covid19-help.org. So we have more than 1,500 substances that are potential drugs and candidate vaccines for COVID-19. So how it works is that the relevant data sources are identified and processed by our AI. The output of this processing is then verified by our scientific experts who classify the results and enter them into our database. Later on, they can also add some additional information about the substances, and it is all available on our website. As the optimization of AI processing is a laborious process that requires a lot of time, money, and work, so it is an ongoing process, and so far it is also supplemented with a manual processing of research articles by our scientific experts. So what our project offers is the current state of research on COVID-19 treatment options and candidate vaccines in both preclinical and clinical stages of development. It is all supported by the article references and clinical trials related to each substance in our database. While some larger projects and hubs rely on AI for processing a categorization of the results, everything in our database is verified by scientific experts and classified manually, which then enables a simple and intuitive navigation in our database and hopefully reduces the time that is required for research. To make our data truly available, everything is freely accessible, so you don't need any registration or accounts to access it, and you can download the results into an Excel file, CSV file, or it is accessible via our API. Moreover, our database is daily updated, and it also provides blogs on various COVID-19 hot topics that are targeted towards a more general audience. A close look at our database shows you that it offers various search, filtering, and sorting options, together with tooltips that can help you navigate into the database easily. You can also use our general search window that is in the main menu on the top of our site, which makes looking up the information you want really easy. So each substance in our database has its own subpage with key information on top, such as a short description and basic categorization like phase of research, how it helps, and the drug status. We also have the total number of supporting references, contradictory references, and clinical trials related to COVID-19. So these also serve as navigation elements that send you directly to the appropriate part of the page. For example, the table of supporting references, where you have the link to the study, some text for better orientation, and some additional notes. So this provides you with basic information on the research article that can help you identify which research articles are relevant for you, and then you can focus on those. Many substances have also other available information such as structure image, formula, synonyms, and other data. So our database was launched last year in April, and since then, there has been a steady increase in the number of substances. So by now, there are more than 1,500 substances. So about a third of those are repurposed drugs, that is, substances that are already used for treatment of other diseases. About the half of the total number are experimental substances, so those that are in development currently. And the smallest group is substances of natural origin, mostly herbal. So our database and the whole project in general would not have much sense without its users. So to reach and increase our target audience, we have used several communication channels. So first, we have been directly communicating with the corresponding authors of the articles that are referenced in our database, and we highly value the increasing communication with them. As we've received some positive feedback, some authors are sending us the newest papers to incorporate into our database. And it is always great to know when the people are actually using the database for their research. So we also have LinkedIn and Facebook business pages where we post project updates. So to this end, we also provide a newsletter subscription to receive regular updates about our project. And we have been also actively posting information on various online forums, such as on ResearchGate, Quora, Reddit, Facebook, and we have also used the EOSC liaison platform. A quite popular part of our website are the blogs that are targeted towards the general audience and not towards scientific experts. And they are quite popular, reaching several thousand views per blog. So a testament to our efforts to share the output of our work with a large audience is the traffic at our site. So since the launch of the website, there has been a significant increase in the number of visitors, which now reaches about 13,000 unique visitors per month. So altogether, we've been visited by about 40,000 unique users from practically all around the world. So finally, I would like to show you the people that are behind the work that I've just presented. If you have any questions, you can ask here, or you can write us at info@covid19-help.org. So thank you for your attention.
Thank you very much for your presentation. There is one question related to your project from the audience. Do you have an ambition to link data from your database to the COVID-19 knowledge graph?
Pardon me, question? If I have ambition to link?
To link the data from your database to the COVID-19 knowledge graph.
Yeah, so we are trying to really promote our product and to get as many people use it, but we haven't done this so far. but we can definitely look into it.
Thank you very much. And now we will try to answer the question to all the presenters. How important was the EOSC co-creation funding program to your project? Did you use it to start something you wouldn't have done without it? Or did you use it to support already ongoing developments? And how strong is the link to the EOSC? For example, are the results and services and data going to be made available through the EOSC portal? Since this question was raised in Ernesto's presentation, maybe he would go first.
Yeah, sure, absolutely. Well, for us, as I said in the presentation, we joined this cause because we felt it was our responsibility to also contribute. Of course, let's say the core of the technology, it's Automaise technology. So it's a technology, it's out there, it's being used by many clients in different verticals. So we clearly see the obligation to put this platform also in this process. So we create a solution built on top of this platform. The solution itself is open source. It's in the node, I said before. So the answer is no. We haven't started, let's say, a new thing with this EOSC. No. What we feel is our responsibility to also contribute, helping fighting this outbreak. So. But again, I think the most important thing we learned from this process was that data is hard to get, label data even harder, to be honest. So we spent half of the time gathering data and labeling data to make this possible, and there should be a joint effort across the European Union or across the globe, let's say, to create these data centers where data is available to everyone. Of course, there's privacy. We need, of course, to put in place some rules to anonymize the data, etc. But definitely there should be some institution that manage data. So the next time we need it, of course, we need it any time, but the data is there, and we can take advantage of it. Otherwise, it will be always like this scattered effort. People is trying to gather data from social media, other from wherever, and there's no this common process in place for data.
Thank you very much. Jamal, what about your project?
Yeah, that's actually a great question, and that is basically, as Ernesto mentioned, this is quite a longest-standing challenge, having access to data and making your research and your science, open and transparent. But EOSC has been quite successful. I mean, from this experience that I've got from this project, that they have been quite successful at launching these seed projects, so that this relatively maybe smaller ideas could be realized, and they could be used as a seed project in order to promote them and make them like bigger projects. So it's quite substantial, and it's quite important to make sure that such organizations, that they are in favor of open science and providing cloud or promoting cloud-based solutions. They are also providing funding in order to make your research doable and being realized. So that's definitely, in case of our study, that was a trigger to start basically develop geospatial tools and methods for public health, and especially in a timely issue such as the COVID-19 pandemic. So that's definitely has been quite promotional to us to basically even take it into our teaching, basically. So we are like also expanding this research into our teaching across the universities in Denmark.
Very nice. Andrzej, what about you?
What was the most important thing we need to pay for was labeling. So our students spent 700 hours on labeling. the dataset. So that's of course we started the project before, so we were monitoring, but just doing automatic analysis without labeling data, and we reposited our labels dataset. So I think this is the most important outcome and delivery what we could produce, because the analysis can be by government from public media monitoring agency, and they are doing. Our government, local government, used to use this resource for political marketing. So they know how to buy reports from brand marketing company which monitor the media, and they doing that, but they got a service with the product which is a report, and this is not replicable, because the agency which collected data on their own and they do some labeling and do some analysis, this is their secret, because this is how they make money. So what we think from more scientific or more open society perspective is to give label data to everybody can use it, even the company. I know they are using our data set to increase the power of the machine learning. But yes, I without money for labeling, it is impossible to run this project. So thank you.
Thank you very much. And last but not least, Ivana, what about your project?
Yeah, so the financial support of EOSC helped us greatly. So we had the idea for our project even before finding this grant, but so we have already started on a smaller scale, but thanks to the financing of EOSC, we could really start it properly, because all of you know that anything with AI requires lots of money and resources. So I wouldn't say that we would not have done our project without the support of EOSC. We probably would be looking for other sort of financial support, but it definitely helped us greatly to develop our project and to get it to the point where it is now.
All right, thank you very much. Since we are now through to all the presentations, we will start with the roundtable discussion now. Andrzej, how do you think will fair data and open science practices specifically improve future research responses to similar European or international emergencies?
So in public health communication practice, there's very important new phenomena which appear, which we call guerrilla or participatory epidemiology. So social media users, they, for example, if they get pre-treatment, they describe what the treatment they get, and they feel this symptom survey, and we look at that data, and we think this is very important, a new possible way of analyzing the epidemiology in this outbreak, in future outbreaks. The users describe the adverse effect after vaccination with data information, which vaccine they get, what was the symptom, and so on. And they also include the laboratory tests, which can be interpreted, and they have their own groups. And the data is open, and this is community-based epidemiology with open data, and everybody can analyze it. And this make like a separate alternative way of collecting even surveillance data. So the people also build their own databases of infections registry, which, for example, in Eastern Europe doesn't work well enough, and some researchers trust more in this community based approach of collecting and listening data than from official sources. So that's something which is going now, and we probably need to understand it for future outbreaks. And for sure, the national registry, the ECDC must strengthen the way of collecting epidemiological data, but there's a new source of data to be understand and to be somehow used. This is this community-based projects, and we need, of course, understand that the quality of this data is not as good as those we, for example, I'm doing in clinical trials in my hospital, but we need to understand this new phenomena.
Thank you. Ernesto, how do you think fair data and open science will help there?
Yeah. One thing that we've learned from COVID is that data is not enough. So and it needs to be open. So it needs to be accessible. It needs to be have quality. And if we all contribute for that, of course, the better data we'll get. And that contains lots of knowledge that needs to be, that can be extracted from. If we combine all these sources from the medical information, social media, sensor data, and combine this into one centralized repository, imagine the things you can extrapolate out of that. Because what I've seen today from Jamal, from Andrzej, from Ivana is that we are all working with data, with different data sets, but they are all separate. One owns one data, of course. It's now stored in some open source repository. But again, everyone was kind of build its own data set. Imagine if we combine all this data into one single data set and have everyone having access to this data set to create AI models, to extrapolate things, to predict the next pandemic, to predict how the outbreak will progress or it will fade away, hopefully soon rather than later. So yeah, definitely open data. It's key for being more prepared for things like that in the future. Definitely, I think we have to now invest a lot on that to be better prepared.
Yes, exactly. Thank you very much. Ivana, what would it take to encourage you and researchers from your field to give access to your data, and what are the biggest barriers there? You're still muted.
I see. Okay. So I think that the positive side is clearly visible. So there is the public benefit because open access data can attribute to scientific progress, and also you can see that research articles that are open access, they have increased visibility, so you have more citations and so on. But I think that the biggest barrier is that science is, in my opinion, still a bit more of a competition than a collaboration, and that you are often pressured to publish your data well, so publish it in high impact journals to receive good funding. And when not everybody gives access to their data, and you do, then you take the risk that somebody, because there is always a lab that has better equipment, more people and more finances than you at the moment, that they take your data and they can finish the work quickly and they publish it better, and then you cannot publish it. So nowadays there is this risk, I think. And what would happen, I think, is that we need, so scientists in general need to be highly encouraged to give access to their data, and this encouragement or pressure should come from two sides, I think. One is the funders, so it should be a condition for financing your project that your data should be open access, and also the pressure should come from publishers. And again, that it should be a condition that to publish in this good journal, you need to make your data available. So I think that the pressure from these two sides, so the funders and publishers, could really help change this reluctance of scientists to give access to their data.
Thank you very much. And Ernesto, what do you say?
Yeah, I agree, definitely. So if we have this like a competition, then of course we are kind of being the blocker and the barrier about the progress, because if everyone is kind of siloed on its work and not sharing, and then the knowledge, the data, and combining all these different brains and this huge brain power that we have across the world, definitely we are being selfish. We are not being, let's say, contributing to the general well-being, and definitely we need to kind of be more collaborative than competitive, right?
Yes. Jamal, what does it take to foster interdisciplinary research in Europe and beyond?
That's actually a great question. Answers might vary from discipline to discipline, but in my opinion, not opinion, also in my experience, it's quite difficult to establish a multidisciplinary and interdisciplinary network. That takes a lot of, most of the research that we are doing across our own disciplines and subjects, they are interdisciplinary, and they require input, and they require a good connection with other disciplines. And it always takes a lot of effort to establish such networks. What I would maybe mention as an example is that what we have seen here in Europe, which has been done through European Commission, is this great cost action networks that they have been established for the same purpose, so that different stakeholders, people from academia, people from industry, people from commercial organizations, and people from, let's say, public authorities, they could come together and establish a network around a subject, so that they could run a very, let's say, sound and dedicated research. So such networks have been there. Cost actions have been out there, which have been quite successful, I would say. But maybe what is needed, or what could be done about them, is just to make sure that we have a good diversity of subjects. And that by that I mean emergency subjects about emergencies such as this pandemic, or maybe the next challenge would be issues around climate change, that we never know what's going to happen with climate change. Of course, we have our projections about climate change, but nothing is for certain, and we might be surprised in different ways. So that's quite important, just to have some imaginations about what could be the worst case scenarios in different emergencies, that we prepare our societies and our infrastructure about them. Thank you.
All right. And Andrzej, what do you think?
I think this is last year was outbreak of interdisciplinary collaboration. I am in a very special position, because as being epidemiologist, everybody asked me for advice, and I was advising in diagnostics, in outbreak investigation, in AI and natural language processing applications. So, and I work with geographers, doctors, I think almost every kind of discipline now is on the board because of the pandemic. So, but I think what is the most important to increase the interdisciplinary is to focus on a given problem. And for example, our case, health communication and understanding the information propagation processes. This is what we look at with media researcher, journalist researcher, medical doctors, IT guys, with natural language processing, sociologists, ethnologists. You know, this is the ground. The pandemic is interdisciplinary from itself, and if we start to work on the project, people come out, because the problem is, of course, money, but at least in the beginning of the pandemic, people work with us on a voluntary basis. So with this project we could pay students, yes, for labeling, but we could not pay our experts, sociological experts, ethnological experts who are collaborating with us, or policy makers who also give a feedback about our results, but they still want to collaborate because of the pandemic. So I am optimistic in this sense that and so many volunteers, people who spend their own time, own money to do surveillance, for example, and they don't expect to be paid for that, and we just need to get in touch with them and maybe give some advice. For example, if they reposit their own health data, yes, and about how they what is the natural history of the infection. This is for free, and this is just to change state of our minds, that the clinical trials can be done only in lab and in a special context with FDA, EMA, or another monitoring authority will lead it. So it can be also done by people, and that's what's the interdisciplinary is in pandemic, and we just need to help it, or at least do not harm it.
In your opinion, what is the best example for success of the European and global scientific response to COVID-19, and where did it fail?
Okay, the success is the hundreds of new substances, what Ivana was showing. So 700 new substances which could be used for treatment or for prophylaxis. Yes, so huge development in diagnostics. So the vaccines which appear in 1 year. So this is a great success, but there are also some failures. And the main failure of European Union, in my opinion, is that the substances which were used for other treatments and they were registered, but the license and patents expired, were not going into clinical trials in European Union. So other countries from Asia, America, Latin America, they also used other treatment possibilities and do clinical trials on them, which is not commercial clinical trials. European Union, I think, in my opinion, wanted to be too innovative, and the possible solutions were there on the market, and for some reason they could be tested in UK, in US, in Brazil, in Bangladesh, India, Egypt, but not in European Union. There was no incentive to do clinical trials on substances which were already registered, and the safety profile were low, but we don't know how effective they are in the clinical aspect of COVID-19, and that's, I think, it was also the reason why this phenomena of guerrilla partisan epidemiological communities appeared, because they read scientific research from other countries, but they see that in their own European countries they could not use some treatment which is available outside of Europe. I don't judge is it good or not to use this treatment, but at least to verify the efficacy. I think this is supposed to be much more stressed by EMA or ECDC. And for example, if we are looking at the guidelines, so in Europe, we don't use ECDC, EMA so much because they are too slowly. So if I want to look at the guidelines, I'm checking ECDC or WHO. ECDC is actualizing the guidelines once per few months. And you know what is this pandemic, how the knowledge arises. What is already a recommendation by ECDC or EMA is already outdated, and for some reason in CDC in US they can do it. In MLA in UK they also update it much more frequently. That's my concern about that's maybe, I know there are some bureaucratic procedure which make it slower. For us, field researcher and field practitioner, this is making a problem if trust in institution, which we should not, because the European Union is a great idea, and some people in Europe is lacking this perspective, probably due to the pandemic.
Thank you very much. Ivana, in your opinion, what does it take to foster interdisciplinary research in Europe and beyond?
So I think that fostering interdisciplinary research is very important, because I believe that this kind of research is the future of research. But I think that we can agree that it is really outside of our comfort zone, and it requires a lot of communication and cooperation. So this is definitely not the easiest way to do science. So what I would offer, my opinion, as a person relatively only a few years out of university, I think that we need a change at the level of education to make young researchers think differently about interdisciplinary research, because from my experience, currently the education system is extremely specialized. And so people are very, very focused on their own field, but they don't see anything outside of their specialization. So I believe that young researchers would greatly benefit from more introductory courses into other fields, and that universities and Academy of Sciences and other institutions should actively encourage interdisciplinary projects and students from various fields actively collaborating on projects to normalize this kind of research and to make the young scientists think about science differently.
Thank you. Jamal, how do you think research will look like in 5 to 25 years, and what will be the effect and impact on research environments like infrastructure, services, and policies? And how will this help facing future emergencies?
Well, that's more a tricky question, I would say. I mean, always predicting the future, especially in such a world that things are changing very rapidly, especially the digital technologies and the technologies. It's hard to basically look into maybe a longer time frame, 25 years, but maybe that is doable for maybe 5 to 10 years, in my opinion. And maybe the way I should phrase it is just what I would like to, or what I hope to see in that time frame in 5 years time or 10 years time into research. And that would be, I mean, today we have all agreed upon the fact that it's quite important to have access to data, to make data openly accessible. And at the same time, go for open science. I mean, this is not something new. It has been going on for a certain period of time, but it's quite important to make sure that this becomes a trend and that becomes a new normal, that no research gets published or comes out without being fully transparent. Because if things are not transparent, then there are some uncertainties and some questions about the quality and the reproducibility of them. But what I would like to see in the next 5 to 10 years time in research, especially from my field of research, would be just to see an ecosystem of infrastructure, digital infrastructure and services that we basically could be saving our time from collecting data, from doing developing tools or applying tools or doing some processing on the data that we are going to study upon. And that requires to develop such cloud-based infrastructure and services so that we basically save our time from this maybe boring or kind of time-consuming tasks of data collection. So that requires also to make sure that the governments and local governments also come into play so that they open up their data that we could use for our research. And at the same time, we could see, in addition to data and tools being openly available and accessible, we could see an ecosystem where different stakeholders also come into that ecosystem, that we could see that not only scientists and academic people just do the research, but also making sure that the research being done is also transferred to final decision makers and final users. One example that I have that maybe in our field has been quite well developed is the availability of Google Earth Engine and Microsoft Azure. So that basically in the old days, or maybe a few years back, we had to just spend days and weeks to just pre-process our data so that we could just start doing the real analysis. But nowadays, the task of or the time of doing those kind of pre-processing has been minimized to a matter of seconds and minutes. So such digital infrastructures in the cloud would be quite helpful to basically save our time from just collecting data and being ready there, because we are moving towards smart cities, smart societies, and smart citizens. So the main need there is just to have also very smart infrastructures as well. Thank you.
Thank you very much. And Ernesto, what would you need the EOSC to be to support you in your research, and what would be the main added value?
So first of all, we are not a proper research institution. I think it was clear already. So we are a company that, of course, has it in its core AI technology. We ourselves are developing a platform that will also streamline all this process of data cleaning, pre-processing, etc., as Jamal was mentioned. So we are also doing that in a super low-touch way. But how EOSC could support us? Well, the thing that we kind of feel a bit, let's say, frustrated, let's say, it's about the next step, because we have been doing all this work. I know for most of the researchers, it's about releasing a paper or sharing with the community the outcome. But for a company like ours, we see ourselves as producing something that then will be used by the outer world, by people, by the community, right? So one thing that we like to have in some program, I don't know if it will be EOSC or any other institution, is about having a way to fund, let's say, the actual proper go live of the solution. So we have built something, it's done, it's working, but now when we try to go to the next step, we don't have funding. That's a true fact. So everything, it just goes to a paper, there's a report, a nice report, there's a drop in Zenodo, but then we always feel this bitter taste about, okay, and having this being properly used by the population, and that's where all these programs fall short. It's because they don't have the next phase. Well, for a company like ours, and of course for a project like ours, because it's our project clearly asks for a go live, right? So in terms of the research, I think EOSC already does a great job. So they've been super supportive, the funding, all the process, etc. But now we don't have the next step. Sorry, and that's exactly where we think that should be a program, some sort of funding that will help us put this live to the community, because it's where the actual value is. It's when you start delivering this to the population, people start using and getting value out of this. Okay.
Thank you very much to all of you for insights in your 4 projects, as well as the exciting discussion now. Time is running, and I think we have to close this webinar now. but I hope that we can see each other soon, maybe in real life sometimes.
Yeah, that will be awesome. Thank you very much.
Thank you.
Yeah, thank you everybody for joining this session.
Thank you. It was a pleasure.
Thank
Bye, guys.
you.
Bye-bye.
Take care.
Bye.